we shall continue. So we've discussed the mean, we've discussed the median. Alright, don't shout out the answer. Don't shout out the answer, but just a quick check of what we remember. Which measure of center, which summary statistic can be thought of as the balancing point of the data? Don't shout it out, think of it. Which summary statistic for center can be thought of as the balancing point? Okay, then go ahead. What is that answer? The mean. The mean is the balancing point of our data. Okay. And the way we can think of the median is that half or 50% of the data is larger and half 50% of the data is smaller than the median. Okay, again, don't shout out the answer here, but think of your answer. Which measure of center, the mean or the median, is affected by extreme numbers, such as extremely large numbers? Think of your answer. Okay, so now, which measure of center is affected by extremely large numbers or extremely small numbers? Yes? The mean. The mean is affected by extreme values. Okay? What is the first step we do in calculating or finding the median?
Put it in order.
Put them in order from least to greatest. We must put our numbers in order to find the median. Alright, so those describe two ways, or the ways to summarize center. Oh, here's another question. Again, don't shout out your answer. But which measure of center is preferred for symmetric data, and which measure of center is preferred for skewed data? If you guys remember. So which measure of center is preferred for symmetric data, and which one is preferred for skewed data? Think of your answer. And the answer is the mean is preferred for symmetric data, the median is preferred for skewed data. And even though it might be preferred, the truth is you can calculate the mean for skewed data, you can calculate the mean for symmetric data, you can calculate the median for skewed data, and you can calculate the median for symmetric data. So any numeric data that you have, you can calculate the mean and the median. Can we calculate the mean and the median for categorical data? No. We do not calculate the mean or the median for categorical data. Alright, now let's talk about summary statistics for spread. So when describing a numeric distribution of data, we want to talk about the center, we want to talk about the shape, we want to talk about the spread. We talked about describing the shape last week, and also the center and spread. But we just looked at calculating summary statistics for center, and now we will look at summary statistics for spread. I'm going to list them out here, and then we'll discuss each one. So we have the standard deviation. We have the range and the interquartile range. Which is abbreviated IQR. And discussion of the interquartile range requires finding quartiles, which I will need to discuss also. Standard deviation, the range, the interquartile range, or the IQR, these are summary statistics for spread. We are taking a set of numeric data, and we are describing or boiling it down to just one number to kind of describe what's happening in this numeric data. And we are describing the spread. So we're just taking a single number to kind of explain or describe what's happening with the spread of our data. What is the spread in our data? Yeah?
I guess comment of like how spread out the actual blocks are.
Okay. How spread out the data is okay. That's one way to describe it, I guess.
From the lowest to the highest?
From the lowest to the highest.
To see what the similarity within.
Yeah, it's. Remember, we have numeric data going on here, and we're asking how similar is the numeric data that we observe to one another. Are all the values very similar to each other, or are they all very different from one another? Okay. So think of numeric variables. And if I asked each of you, your height, there would probably be a decent amount of variation. Okay, we have short people, we have tall people. We've got a good variety or a good amount of variation in the height between the different people in this classroom. So we would say there's a fair amount of spread when we're talking about height. Okay, if we talk about weight, there's also going to be a fair amount of spread when we talk about weight. If I asked you, how many fingers and toes do you have? And if we asked this is a numeric variable, right? If we asked you how many fingers and toes do you have, there's probably going to be less spread, okay? I imagine a great majority of you, if not nearly all of you, will have total of 20 fingers and toes, okay? And maybe there might be a few of you who do not have 20 fingers and toes total. However, if we looked at the entire set of data, what we would see is nearly everyone with 20, and maybe just a few people with numbers that are different from 20. So in that regard, that numeric variable, because it tells us how much or how many, does not exhibit very much spread, because nearly everyone has the same value, or very similar values. Whereas when we look at height and weight, we are going to see much more spread. Is that conceptually okay? So when we are talking about the spread in our data, okay, I could say when it comes to height, one number to describe the spread is 3.5. I'm making that up. Whereas the amount of spread when it comes to fingers and toes is 0.03. Okay? I don't know the actual numbers. I made those up. But you get an idea. For height, we have a number to describe spread around 3.5, or when it comes to the spread and the number of fingers and toes we have, that number is much smaller, 0.03, a number I made up. Okay. And that's all we're doing with these summary statistics for spread. We're trying to describe the spread that we have with a single number, where large values of that number indicate a large amount of spread, small values for that number describe a small amount of spread. Okay? So let me just write this. Spread can be thought of as how similar or dissimilar low spread means most values are similar. So is this concept of spread okay? Yes?
Can you repeat what you just wrote?
Spread can be thought of as how similar or dissimilar the values in our data set, I should write, are. Low spread means most values are similar in value. So, how many fingers and toes do you have? Most people would say 20. Maybe a few people would say a different number. But nearly everyone in the data set has around 20 fingers and toes.
Oh, okay.
Large spread means there is lots of variation between the numbers. So we asked, what is your height? What is your weight? The values would exhibit a wide variety or wide range, a wide spread.
Is the terminology specific? Like you say large spread and low spread. Could you say high spread and
Small.
small spread? You know what
Yes.
I'm saying?
These are just generic.
Okay.
So
Thank you. That's what I need.
spread is just kind of a conceptual thing.
Okay.
We are going to zero in with actual values with standard deviation range, IQ. So the standard deviation this can be thought of as the typical difference or typical distance from the mean. Okay. What is the typical distance from the mean? And typical is, it's a little bit strange. But you can think of this as what is the typical distance from the mean. All right. So imagine two campuses, right? College campuses. So let's say so there's like a private school, I don't know, Loyola Marymount. Okay. A large percentage, many of the students attending that school live on campus. If you think of, I don't know, Santa Monica University, or not, or Santa Monica College, sorry. Santa Monica College. Are there dorms? Do people live on campus?
Mm-hmm.
No, right? Everybody commutes, okay? Now, most people live close to Santa Monica, but some people commute a good distance. So if we asked students at Santa Monica College, how long did it take you to get to class today? And if we went to LMU and we asked, how long did it take you to get to class today? Well, what kind of numbers do you think you would see at LMU? Yeah, small numbers, okay. And at Santa Monica College, what kind of numbers would we see?
Hour, half hour,
Larger numbers, right?
3 hours.
Okay. So some people are complaining about how hard their life is right now. So one thing that would capture that would be the center, okay? So the average for LMU might be 5 to 10 minutes. The average for Santa Monica College might be 35 or 40 minutes, maybe an hour, 60, whatever it might be, okay? It might be much larger. So the center is different. But then we also can look at the spread. If we looked at LMU, maybe the person, maybe 90% of the students only take between 5 and 10 minutes to get to class. Maybe there's just kind of a small range. Whereas if we think of Santa Monica College, will some students only be, maybe it only takes them 10 minutes to get to campus? Yeah, there's a few, all right? So a few lucky people who only take some 10 minutes to get to class, sure. And then will there be unlucky people that take 2 hours to get to campus? Possibly, depending on the time of day and what happens on the freeway. But yeah, it might take some people very long to get to campus. And so you have a wide range or large spread in these things, okay? Standard deviation is what is the typical distance from the mean? Here we have the mean, the distance is not the right word here, but yeah, the deviation from the mean. So let me just do a few, we'll start off with an example set of data, small set, and we'll talk about the standard deviation here. Okay. So we'll talk about commute times to campus. All right. So let's say at SMC somebody took 10 minutes to get to their first class, somebody else took 45 minutes, another student took 30, and another, huh? 25. Great. Okay, so let's say we have these 4 values. And we create a number line to display this, okay, the dot. Okay, I have a dot plot showing the 4 values. What is my mean? My mean is 27.5. Do we see that? Can we get that? Problems there. So if I draw a line at the mean, this is right here, okay? This is my balance point, and my mean is located at that line. So far, so good. Yes? No? Okay. How far is this point from the mean? This person's commute was how long? 25 minutes. How far is this person's distance from me? This guy took 2.5 minutes less than what the mean value is. So this person's distance is 2.5. How far is this person from the mean? 17.5. going to just pause here. I just want to make sure that we can see. This says 2.5. There's a decimal there. It says 17.5. So this person's commute time is 17.5 minutes less than the mean commute time. I want to make sure that's okay with it.
You're just calculating the difference.
I'm calculating the distance from the mean.
Okay.
Is that okay? And by coincidence, maybe because I didn't pick my numbers so well, by coincidence this also is 2.5 and this one is also 17.5, okay? That just happens to be a coincidence. It's, huh? And it's also the median, also coincidence.
How did you get 17.5?
How did I get 17.5? Okay, what is my, for which one? Which 17.5? Either one. Okay. Okay, so what is, are you okay with that the mean is 27.5? That's okay? Alright, so how long did this person take to get to campus? 10 minutes, okay? So if the average amount of time it takes to get to campus is 27.5 minutes, and this person only took 10 minutes, how different is that person's time from the average?
It's all 17.
17.5 minutes. Okay. That's all I'm doing. Okay, I'm just saying, how different is this from the average? Okay? And so, the difference from the mean, or what we would call the deviations that I have are 17.5, 2.5, 2.5, and 17.5. Okay? You're not always going to have this symmetry in your data. It's just a coincidence with the numbers that we happen to pick. But we have 17.5, 2.5, 2.5, and 17.5. And we have to ask, well, what could be considered the typical distance from the mean? So some people's difference from the mean is small, other people's difference from the mean is great. What is the typical distance from the mean? Okay. And that's how we count. That's the idea behind the standard deviation. Okay. Now some of you might say, okay, well let's take 17.5, 2.5, 2.5, and 17.5 and take the average of those. Okay. That might make sense in one case, but that is not what we do. We make things a little bit more complicated. And I apologize for that. There is a good reason for it, but I fear that the explanation behind the reason is just going to make things more confusing, so I'm going to avoid it. Okay?
The reason why we don't do 17.5, I'm sorry, what was that? I'm sorry.
So I've calculated the deviations from the mean, okay, which happen to be 17.5, 2.5 for this point, 2.5 for this one, and 17.5 for this one, right? So I have 4 deviations, and someone might suggest, well, let's add those 4 numbers up and divide by 4 and get the average, okay? And that would actually be reasonable, but that's not what we do, okay? So don't write that down, okay? That's not what we do.
I just found this 4 deviation.
Because, yeah, we have 4 deviations. We might ask, what is the typical deviation? Okay, so again, there is a good reason why we've made our lives more complicated, but the reason is in and of itself complicated, and it happens to be the squared properties of distances. But let's just talk about what we're going to do. Okay.
What normally you wouldn't have that 17.5, would you, like, given to you? Like, you would have to, we have to get the mean in order to get that 17.5.
Exactly. So that goes into the process of calculating our standard deviation. We have to find the mean, and then we have to find out how different, or what the distance from the mean is for each of these values. Okay. So I'm going to write these steps. Essentially what we're going to do is we're going to square these deviations. We add all of those squares up, and then we divide by n minus 1. Okay? That's just what we do. So let me, I'm going to just write the steps for finding the standard deviation. Okay? But is the concept of a deviation okay? Yes? No?
Yes.
Yes. Okay. Okay. So to find the standard deviation, Step 1, find the mean, okay? That is the first thing we're going to do. Step 2, find the deviations from the mean. And how do we find the deviations from the mean? We just subtract the mean from each value. Okay? And the next part is finding the typical deviations. So we find the mean, now we found the deviations from the mean. And now we're going to find what is the typical deviation from the mean. And to do that, first we square the deviations. We add them up, add up the squares, add up those squares. And you would think we would divide by n, but we divide by n minus 1. Divide by the quantity n minus 1. And then lastly, we take the square root of that. I'll let you guys finish copying that down in your notes, and then we'll find the standard deviation together. Are we ready? No? Faster, faster. Okay, ready or not, here we go. So, I'm going to use these 4 numbers that I have. So my commute times, once again, are 10, 45, 30, and 25. The very first thing I do is I find the mean, and I've already done that. X bar is 27.5. Any issues with that so far? No. To find the mean, we add up the 4 numbers and we divide by 4. And the second step, which I've already kind of done, what I'll do here is we find the deviations. Okay? So to find the deviations, I'm going to take this value 10 and subtract the mean, which gives me negative 17.5. I subtract the mean here. And again, just coincidentally, I happen to get 17.5 and negative 17.5. Now I regret my choice of numbers, but I've already made my decision, so here we go. So these are the deviations that I've calculated. All I've done is I've taken this mean value and I've subtracted it from each one to get the distance from the mean. Okay, so this I'm just doing numerically what I did over here visually. Here I said this is where my mean is located, and I'm finding how far are each of these data points from the mean.
It's a negative 17.5, right?
The first one is negative 17.5, and the second one is positive 17.5.
Oh, we have to notate that it is negative.
Well, in the next step it doesn't matter, but yes. negatives and positives do make a big difference. I would much rather have positive $1,000 than a negative $1,000. So it does make a big difference. But in the next step, when I square all the numbers, what happens when you square a negative number? It becomes positive, okay? And I just want to make sure that we all know squaring a number means what? Multiplying a number by itself, not the square root. Some people don't know the difference between squaring and square root. So, 17.5 squared, or negative 17.5 squared is equal to, I don't know, a big number. I'm not this good. $306.25. Okay? So notice a negative number squared becomes positive. Now some of you are going to type in negative 17.5 squared in your calculator and it's going to return negative 306.25. What is going on there? Why is this? If you type this in your calculator, you're going to get this. Is this the correct answer? No. Why is this incorrect? Okay, yeah, you have to put the parentheses around that, but why does this give us negative 306.25? Doesn't the calculator know that a negative number squared is positive?
Not squared, it's two.
The negative is not squared.
Yeah, negative.
It's outside of the parentheses.
It's negative.
Order of operations, what do you do? Exponentiation before multiplication, okay? A negative is essentially multiply a number by negative 1. So you were doing the squaring first and then you were multiplying by negative 1. That's why it's going on. So don't make that mistake when you type it in your calculator. Make sure all of the numbers you get are positive. So that is step 3, square the deviations, and these are the numbers that I get. Is that okay? I'm taking these things and I'm squaring them, and I get that. So step 3, these are the squares of the deviations. What does step 4 say? Add up the squares, okay? So what do I get? 625. So if I add all of these up, 306.25 plus 306.25. If I add these up, I get 625. What's the next thing I do? Divide by n minus 1. What is my n? 4. 4 minus 1 is 3. So I do 625 divided by 3. So step 5 would be 625 divided by 3. And what does that give me? 208.33. 208.33. If I were to stop at this point, this number is known as the variation. Okay? Now some people use the variation or prefer the variation, but it has a difficult interpretation. So we use the standard deviation, and the last step is take the square root of that number. So I would take the square root of 208.33, and what is that value? 14.43. This is my standard deviation. Okay, yes. Question? Yes.
Sorry, I lost you for a minute.
You lost it for a minute.
No.
Okay.
How did you get 625 divided by 3? Where
Okay. So I'm just following the steps. So 625 came from step 4. That's good. Step 5 says divide by n minus 1. What is n?
Oh.
N is the sample size, which was 4. N minus 1 is 3. No, that's a great question. Okay? So 4 minus 1, because n is equal to 4. So I do that, I divide by 3, and then I take the square root of that to get my standard deviation. I'm sorry?
So I think, so the standard deviation, if you were to subtract it from the mean and add it to the mean, so all, you get what I'm saying by all the area in between, to the left of the mean, 14.43 spots, and to the right, 14.43 spots. Would those be the points that were under that standard deviation? You know what I'm saying? And everything out of it would be outliers?
What you are referring to, I will talk about in a little bit, okay? And that's not how we determine outliers, but that will be the next topic. But I just want to make sure we can do the standard deviation first before we get into that. Okay. Yes.
Sorry, I got a little confused why we divide by 3. I know that you do n minus 1, so it would be 4 minus 1, which is 3. I don't know if I got it right. And then after, what is it over? Like, what are you dividing by?
So 625 divided by 3.
No,
So-
then I understand. I mean, I guess I'm going back to the first step. Would it be 4 minus 1 over what? Does that make sense? Do you understand my question? Like, if I'm going back to the first step, like the very first step. in order
Finding
to
the mean?
Getting the mean, yeah.
Okay.
I don't know.
But this is finding the standard deviation. It's a different formula is what you do in order to get the standard
Right, so I guess
deviation.
I mixed up what the formula is.
It's two different things. One is
All right, so
n
this is,
divided by 1 over 2, and the other one is n minus 1, and that's how you find the standard.
Oh, it's just improvised.
Yeah,
Yeah,
it's
now I
totally
understand.
Okay. I could write the formula for the standard deviation now. I'll do that. Okay. You want that? All right. Don't get mad at me that you asked for this.
That's too much.
Okay. That's the formula for the standard deviation.
Is that x minus
Oh, okay.
Is this good?
No. That's the formula.
Huh?
You don't want us to put that on the quizzes or anything?
If you okay, this is my thing about formulas. Shh. Quiet. Be respectful, please. Formulas are great, okay? If you know how to use them. If you can read formula gibberish, great, and use it, okay? Formulas guide you through these steps. What I find is people think formulas are magic, but they really don't know how to use a formula. And they see these letters and they just try to throw in numbers hoping that they're putting in the right number in the right spot, but they're not, okay? And then you do that, you're going to get the wrong answer. So this formula summarizes everything that I've written over here. Is this more legible? I don't know, okay? I mean, so the very first step says finding the mean. That's given by this x bar, right? Finding the mean. The second thing says find the deviations of the mean, and then we see that by doing x minus x bar. Third step says square the deviation. So we take that quantity x minus x bar, which was the deviation, and we square it. The fourth step says add up the squares. So we have the summation sign here. Fifth step says divide by n minus 1, and that shows up here. And the sixth one says take the square root of that, and that's the square root right there. Okay, so this shows everything that's in that thing. If you like this, great. If you don't bother, okay? Do what's comfortable for you. Learn the way that you learn best. I have a feeling if you understand the standard deviation formula, then you're fine, you're set, okay? I also have an inkling that for most of you, this makes more sense than that,
Yeah.
okay? Something tells me. So anyway, we followed these steps and we arrived at 14.43 as our standard deviation. Okay?
How many decimal points do you want to add after? Does it matter?
I don't know. I would say my general rule of thumb is around 3 decimal places. I know I only use 2 right there. Okay? But I would say generally around 3 or 4. Depends. 2 is not the end of the world. Okay, so let's just check to make sure you understand what to do. And so let's go over to Loyola Marymount, and we'll talk about the commute times there, or time it takes to get to class. And let's say these numbers are 10, 5, 15.
This is just an example, right?
Yes. 12. Alright, so now I leave it to you for a few minutes to calculate the standard deviation. And again, you know, to make your life easier, I'm going to add in one more number, and I think this will actually make your life easier. So there are 5 numbers in commute times. It says 10, 5, 15, 12, and 13. This is how long it took them to get to campus or class. And I'm asking, what is the standard deviation of these times? So take a moment. Some of you are drawing pictures, and that's great, but it's not required. All I'm asking is for you to find the standard deviation.
Third number in the sequence. So there's 6. Yeah. So there's 5 numbers. 1, 2, 3.
Yeah.
The third number is
What would you say on the It's so weird, 'cause I got a difference.
Okay, I already put the answer up. How are we doing? More time? You got it? No? You got it, that's great.
Find the deviation, is it mean subtracted by the value or value subtracted by the mean?
It should be the value subtracted by the mean, but in all honesty, it doesn't matter.
Oh, got it. Because you're gonna